This time I'll discuss composition of functions. The composition of functions is an operation where two functions, say f and g, generate a new function, say h, in such a way that h of x is equal to f of g of x. Okay? It means that the function f is applied to the function g of x. So basically, here a function is applied to the result of another function. In other words, composite functions are functions within a function. Composition of functions is also denoted by f of g of x is equal to f of g of x, where this symbol here, a small circle symbol, denotes composition of functions. The small circle symbol cannot be replaced by a dot because this dot here represents the product of the two functions f and g. So meaning to say, the composition of functions f of g of x is not equal to the product f times g of x. The following are two of the properties of composition of functions that we need to remember. First, composition of functions is associative. This means that the result is the same regardless of the way the functions are grouped together to form the composition. Second, composite functions are not commutative. Commutative property involves carrying out an operation in which even if the order of the entities involved in the operation is changed, the answer still remains the same. Again, composite functions do not follow the commutative law. Let's have an example. Here we let f of x be equal to 3x minus 1 and g of x is equal to x squared plus 2. We'll find for g of f of x and f of g of x. First, we'll find g of f of x. Then later on, f of g of x. Okay? So this will now be what? This will be equal to, take note of this first function. This will become the main function g. Okay, so this will now be g of the second function f will then be that considered as the independent variable for the function g. Alright, so this will now be what? Okay, bear in mind that again, the function g is the main function, so therefore it should take this form x squared plus 2, right? In other words, this must be equal to something like x squared plus 2. However, since we have this f of x defining the function, we can initially have this as x star, okay, for us to be reminded that this variable here is different from that variable in the original function g of x. Okay, now what's this? F of x. Okay, this tells us that whatever this expression for f of x, which is of course equal to this one, 3 of x minus 1, shall be replaced, or shall be replacing this variable x star here, so that this will now become 3x minus 1 quantity squared plus 2. Okay, of course we need to simplify this. We do so by applying this square of the binomial 3x minus 1. To recall, it will just be what? The square of the first term, 3x, okay, which is 9x squared, okay. This is minus, so the second term will be minus twice the product of the first and the second terms to have minus 6x, okay, And the third term will be the square of 1, which is, of course, positive 1. Then we have here plus 2. Simplifying further, collecting like terms, the final answer will then be 9x squared minus 6x plus 3. Right? Now we'll find f of g of x. Again, this will be what? Take note again of the first function there. This will then be equal to f of the second function is g. So this g of x will now become the independent variable, okay, to define this function f. Okay. Now this 3x minus 1 is the original expression for the function f. Hence, this function f of g of x shall take this original form. Okay, meaning to say this will now be equal to, okay, something like 3x minus 1. However, for us not to be confused, we need to rewrite this x as x star, something like that. Okay, then take note, this is g of x, okay, which is now the independent variable to define the function f. Okay, and g of x is equal to x squared plus 2. So we'll plug in or replace this variable x star by x squared plus 2. Okay, so this will now become 3 times x squared plus 2 minus 1. Simplifying further, this will now be 3x squared plus 6 minus 1, which is of course equal to 3x plus 5. Alright? In my next video, I'll be discussing about inverse of functions. Thanks for watching.